So I'm working on vectors and spherical coordinates, and this is I think this will be my last video. So if you describe a particle in spherical coordinates, then you have to have spherical unit vectors in the r hat, phi hat, and theta hat direction. Now, quick note, I'm using phi to represent the angle between the z-axis and the position. Okay, some people use theta for that. So if you do that backwards, that's you, you be you, and I'll be me. And then in the first video, I derived r hat, phi hat, and theta hat in terms of Cartesian coordinates, and we do that because when I take derivatives, the time derivatives of Cartesian coordinates are constant because they don't change direction, but the spherical coordinates do change direction. So in my second video, I took the derivative of r hat with respect to time and got it back into spherical coordinates, and then I did the same thing for phi hat and theta hat. So if I have the position of an object in spherical coordinates, it's just going to be the distance from the origin times the unit vector, which is the same thing, right? It's just r hat. And we write this stuff like this all the time, and that's why I like using r for spherical coordinates. Some people use rho, but I like to use r. Now if I want to find the velocity is just defined as dr dt. So I just need to take the derivative of this. So the derivative of r is going to be equal to r dot. So it's r dot r hat. But it's a product rule. As this thing moves along, r hat's going to change directions too. So I need to take the derivative of this. It's a product rule. So I'm going to take the derivative of r with times r hat plus r times the derivative of r hat. So it's going to be plus r times dr hat dt. Now in Cartesian coordinates, dx hat dt is 0, like I said. Now I just did that. I already did dr hat dt. So I get v equals r dot r hat plus r times this. So it's going to be r theta dot sine phi hat plus r phi dot phi hat. And that is my velocity in vectors in spherical coordinates. That's not too bad, right? Okay. Now, what about the acceleration? I'm going to skip to a new piece of paper because let me write it over here. Acceleration is going to be equal to the derivative. Oh, and just to be clear, r dot equals dr dt. The dot notation, if you haven't seen that before, we just represent a derivative with respect to time as a dot above that. And a second derivative would be 2 dots above that. So the acceleration is going to be dv dt. So I have to take the derivative of this with respect to time. So let's do that. Let's write that up at the top. So I'm going to write it right here so I won't forget. So v equals r dot r hat, that's a hat, plus r theta dot sine phi hat plus r phi dot phi hat. Now, I'm going to need to remember these things right here too because I'm going to need to use this. So I'm going to put this paper up here so I can see it. And if you write that down off to the side, you may need to reference back to that. Okay, so dv dt. Okay, let's just start taking the derivatives. Remember, I have to include product rules. So I'm going to take the derivative of r dot with respect to time. That's going to be r double dot times r hat. Now I need to take the derivative of r hat. So it's going to be plus r dot times the derivative of r hat. So I'm going to look at my table up here, and I see that's going to be equal to theta dot sine phi theta hat plus r dot phi hat. So this whole thing is the derivative of that term right there. Now this term, you can see I have 1, 2, 3, 4 terms in there that all can change with time. So hold on to your butts, okay, because this is going to get a little messy. Let's do that first term plus r dot theta dot sine phi hat. Now I'm going to do this term plus r theta double dot sine phi theta hat. Now I'm going to do this term plus r theta dot. Now when I take the derivative of this, I'm going to get another phi dot. So I'm going to get a phi, because I got to take the derivative of sine phi is cosine phi dot. So there's my phi dot. Cosine phi theta hat. Now finally this one, I'm going to go down here, plus all that stuff, r theta dot sine phi. The derivative of theta hat, I'm going to look at my table up here, and I get, I'm just going to put it in parentheses for right now, negative theta dot sine phi r hat minus theta cosine phi. I think that should be a theta dot. Did I make a mistake? Yeah, that's theta dot. You know how I caught that? I'll tell you in a second. Phi hat. I caught that because I know this is a time derivative, so it needs a time element in there. Theta, it doesn't have, theta dot is radians per second. Theta is just radians. So I knew that was missing a dot. Okay. So that was, where was I? That was this term. Notice these three pieces are that term. All of these are from the derivative of that. Now I need one more derivative. I'll put it right down here. So it's got 3 parts. So I'm going to say plus r dot phi hat. That's the derivative of r. Now I need to take the derivative of that one. Plus r phi double dot phi hat. And then finally I need to take the derivative of phi hat. So plus r phi dot, and the derivative of phi hat is going to be equal to, I'm going to write it out, negative phi dot r hat. And what did I have? I had plus. Yeah, plus. So then I have plus r phi dot theta dot cosine phi theta hat. Whoa. Okay, I'm done. I'm not really done. I am done. I really am done. But I want to simplify this. So what I want to do is to gather all the r hat terms together, gather all the theta hat terms together, and the phi hat terms together. So let's say A equals r hat. Let's start with r hat. So I have r double dot. I'm looking for r hats. There's one. Okay, so that's going to be equal to minus r theta dot squared sine phi squared, right? Because I had this times that. And now I'm looking for another, here's one more r hat term right there. I get minus r phi dot squared. Yep. Okay, so those are all my r hat terms. Now let's go for my theta hat terms. So plus theta hat. So what terms have theta hat? Here's one. So it's going to be r dot theta dot sine phi. Looking for theta hat terms. There's one. Plus r dot, notice right here, this is the same as that. So I'm actually going to get 2 of those. Here's another one. Plus r theta double dot sine phi. Here's another one. Plus r theta dot phi dot cosine phi. There's none right there. This one right here. Plus r phi dot theta dot cosine phi. So I have 2 of those. Is that right? Yeah. So this and this are the same, so I'll just put 2 of them. I'm just checking. I think that's right. R double dot, wait. R is, that's right. Okay. Okay, that's that one. And then plus the phi hat terms. So the phi hat terms, I'm going to go through. There's one. R dot phi dot. There's one. So I'm going to get minus r, and then I have a theta dot times theta dot, so theta dot squared, and then I have sine phi cosine phi. Now look, here's another one, another r dot phi dot, so I get two of those. And then I have an r phi double dot, and that's it. Okay, so I'm done. Now I'm done, right? I feel much better. There's my r hat component. Here's my theta hat component. Don't worry about that. Let's just pretend like we just do that. And then there's my phi hat component. So there's your acceleration in spherical coordinates. I did it. Yay me. Okay, and it's 3 videos. I'll include the videos, the links for all 3 in all 3 of the descriptions. Yeah, I'm done. Okay, that's it.